Hey everyone, and good morning. Thank you, and for listening to another episode of the HouseNow3D podcast. My name is Johnny Nelson, and today we're bringing on a very, very cool entrepreneur and innovator, Daniel Weddle, with Tehran Robotics. He's out of Indiana. His company is focused on earthen type of structures. It's 3D related, but he has a unique approach, unique clientele, and a very, very compelling story about all the things their team is doing. And Daniel, thank you for being with us this morning.
Yeah, thanks for having me out. It's been kind of an intense week of prepping our pilot site, so I'm a little worn down, but having my second coffee and talking with other nerds is a good way to start the day.
I like it, man. I like it here. That's an excellent, actually kind of a qualifier there. There's a lot of people out there talking the talk and less people walking the walk, and you guys are definitely walking the walk on that side of the space here. But before we get into the exciting things that your team is doing, let's talk about a little bit of your own background. You shared with me pre-show. You've had multiple careers, really. Have some degrees. Those were kind of those tied into some of the things you were doing here. But give us a little bit of background of where Daniel grew up, and then maybe a little bit of the pre-professional or the professional background that you had before you jumped onto the team with Tehran Robotics.
Sure. So I go way back, military brat. My father was Air Force. I was born at Hoosier, northern Indiana. Jumped out to Washington State for kind of like second to seventh grade. Back into the region I'm in now since seventh grade. I've been in Bloomington 20 years. So some of them jumped around as a kid. This is the most continuous I've lived anywhere. Went to undergrad for business and marketing and sculpture fine art, and then did most of a master's in architecture. I ended up leaving my last semester after getting a National Science Foundation grant and hiring out a team to build Tehran Robotics. Kind of in between undergrad and graduate, worked as a year as a kind of a handyman, learning systems, then a year as a assistant carpenter, kind of the same deal. And then did a number of years as a high-end tiny home builder in the height of that movement. Kind of terminated with building a mobile venue called the Concert Car and doing a house for HGTV for the co-founder of Angie's List.
Was that project fun, Daniel? I mean, like obviously there's ups and downs, but just just kind of exciting little side story here. Was that fun, or what was the upside? And what was the downside of that, or was it just like draining? Which I don't mean to be negative, but like what was kind of your final analysis of that?
The shooting was fun. I'm a very much sorry, my dog is going crazy. I'm gonna introduce him because I'll probably jump in eventually. This is Zuzu, Zool the gatekeeper.
Gotta have the backup team handy.
Yeah, gotta have a pink dog somewhere in your life. The HGTV thing was and probably the biggest inflection point that led to this work, honestly. Before that, I had built for activists and people with like more affordable tiny home stuff. And I really enjoyed it. In fact, the activist was interviewed by HGTV as a potential for the episode. And I still think that's the best house I ever built. It makes medicine in the in the North Carolina mountains to this day. When I did the HGTV one, so I was the co-founder of Angie's List. And it was just like an inflection where I was like, I don't want to do this anymore. Yeah. Working for like super high-end rich people doing stuff that's like $500,000-$600,000 a square foot. Tiny houses are sort of skewed because there's so much contained in them that you can't really judge it that way.
That's fair.
But that said, it was just I didn't want to do that anymore. I went back to grad school for the intention of figuring out affordable housing. Pretty much started right out the gate with earthen research, robotics research. And
what drew you to that, if I could ask that thread? And then just as a kind of a commonality here, the affordable home. I mean, obviously thousands of people are talking about that, but that is a common thread between your team and my team and others that listen to this podcast. Is that attainable? I call it attainable, but sure, affordable home, whatever the right word is, just less expensive housing for your average person, your average family. That's something that really drives a lot of people, drives you. So that's exciting that you kind of jumped right into that. That's kind of like you got tired of the other. Hey, those people have a lot of resources. Let's focus on something that's a real need. But within that, how did you know to kind of zero in or converge on earthen type of structures or type of methodology, Daniel?
My co-founder picked the modality and the material. He came out of the company he was in Nirvana was purchased by Intel. He did that kind of shtick for a little while, and then started doing materials analysis and really lightweight monolithic adobe cost per linear foot for materials theoretically has a point somewhere, half or a third the cost of stick materials for your, like a habitat house. So the cheapest in material. So automation has the best effect there. If you automate stick, for instance, the best you might be able to do is cut the cost of the wall in half, because everything in that ecosystem has been developed over the years to maximize labor. Everything comes in 4x8 sheets because they fit in a truck and the human can hold them. Trucks are built around that shape because people can hold it. All that stuff is sort of, modular in such a fashion that you maximize the yield from a human hour.
Yes.
So that's a pretty efficient system as it stands.
And there's all that, the resources behind that, of course, the massive factories or, mills that make the sheeting, and then the mills and the trucks. And there's like a lot of optimization, but it's a huge supply chain. It goes back, if you keep going back, peeling layers and layers, like there's a lot of optimization, thousands of people, hundreds of factories and all this kind of stuff that goes into optimizing that. And we're kind of like peaked out at that. And there's like, obviously, fraying at the edges with labor and other things, forestry and things like that. But please go ahead, just kind of add that adjacent point there.
Yeah. Complexity certainly plays in. I mean, when you can take materials from a site and form them into a home, you've kind of broken that entire system that you just mentioned there.
Shattered it, Daniel.
Yeah. And then you have sort of the same thing with 3D printed concrete. The prices are coming down, but materials cost per linear foot on all the estimates I've pulled. And I like to pull real estimates from people that are going to do a job for me instead of playing this numbers game that everybody's doing. And about the cheapest I've seen on any of the 4 estimates pulled for my projects is 300 a linear foot for the material itself. And then the labor typically doubles that, and that's without profit. When I see profit backed into it, usually breaks 1,000 a linear foot. I think that ecosystem will shift, but right now, materially, it is somewhere at like 2x the cost of stick out the gate per linear foot per material.
When you say linear foot, I thought just so people have that number correct, Daniel. So when you say $1,000 a linear foot, is that like 1,000 or 1 foot by 8 foot tall or 9 foot tall, or what is that? What's the dimension there?
I like to speak 1 by 8.
Okay, gotcha. Just so people,
to be fair, my quotes on my project were 1 by 10, so you could discount that by 25% and be a little more accurate. So maybe be like 450 to 900 or something.
Sure.
For the estimates that I have like paper to back.
Yep.
So those are the kind of the two. I mean, the primary reason is material cost with the highest labor. That is monolithic adobe across the board. It's the cheapest. Everybody knows it's the cheapest. It's the most expensive to deploy. We don't use it here. Code compliancy changed about a decade ago, and it's been getting adopted more and more in the last few. So there is a path to it now in the US. I think something like 1/3 of the homes in the world are earth. It's just not places with code or earthquakes.
Gotcha.
But yeah,
where if you could point to, just say, I guess, of the curiosity of myself and the audience, Daniel, where in the world would you like to is good to point to or look at and say, hey, this is an engineered smart way of using earthen type of structures? Is like some place in Japan, or I don't know, like you tell me, like where is a model that you are looking to for innovation and doing it correctly, unless maybe there's not, I don't know.
Oh, no, I think there are plenty of examples. I mean, I think in the Southwest, I can't remember the percentage. I'd have to look it up. It's great. It's somewhere in like 50+% make faux stucco. So they're trying to imitate these things that existed there before. There are probably places where HOAs demand that I can't speak to directly.
Sure.
But I think the Southwest, and particularly the CEB block movement has had more traction in recent years. Some 3D printed extruded clays have been making place out there, but they haven't been code compliant yet. Northern England, central, southern England, all of England has a history of building with cob, and the US would call it adobe. I would say historically they leaned more on mass and just thickness of wall to accomplish things, but also Europe doesn't have earthquakes, or not like we do here. So there's a different calculus that goes into it. But yeah, I think those are the two places people come front to mind. I think when they think of England, they think of like hobbits and cottages and those sorts of things. When it's better to think of like taverns where it's like that's more of a communal space and something that feels more like commercial. In the Southwest, there's usually, it tends to lean toward like a more modernist flat roof lines, those sorts of things, just because that
Right.
climate had that style. But I would not call those houses modern.
For sure. For sure.
I think some of them are very well built.
Gotcha. Okay, so that's a good kind of reference point where you're looking to. Oh, and then and then to that point, you see around the world, you laid out the kind of the benefits of the multi-layer benefits, and then you're pointing to a few regions, areas in the world, like the U.S., where they're already doing some of it or whatever. What do you guys hope to take it to the next level? Is it really just or not just, but like definitely the addition of the robotics? And then like the methodology, what is kind of the kind of just, if you had to just boil it down to 3 or 4 points, what are you guys adding within your company, within the team and the innovation that you can bring to this right now?
Well, this is going to be one of those annoying proprietary answers.
Okay, fair enough.
And
Answer
it's
the
something
best you can. Yeah.
yeah, we can discuss more in like 2 weeks because we're about to go public with the
I
new,
forgot that. Yeah, you
yeah,
got
the new
some really
equipment we're using.
cool stuff coming out. Yeah.
And we do have some spots open for the site visitation week running the equipment. So if you or people in your network want it, let me know as soon as you can. I don't know where we'll cap it, but it certainly will be only so many people we can handle. And that's probably going to happen 3rd week of October, 1st week of November, somewhere in that range. But yes, to speak with that proprietary shield on, there are 2 tracks of research we're in. It's producing a deployable, lightweight, monolithic Adobe that carries its R value and is structurally sufficient without a secondary system. That's done through materials research, design, and engineering. Our first build has been performance reviewed. It does not require a secondary system, and it's load-bearing earth. So out the gate, we're deploying that sort of solution. We did not think that would be the case. So we're kind of ahead of schedule on that. And then the robotics, we've ramped up and changed platforms quite a lot since our original drone-based work.
Sure.
And we're looking at the new machine coming out. I think they complete the build this week and are assembling it for testing next. And it's 2x speed, 2x torque from our previous machines. The first machine I look at where I'm like, oh yeah, this is construction equipment. And that's the machine that we'll be like going public with, and then people can come visit. So those are the 2 tracks we're on. It's the deployment. The machine uses pick and place and then shaping. You can see that stuff on our YouTube channel. So that's no longer proprietary or whatnot, but we do not extrude. That's one of the big differences between us and other folks is we pick up the material as it's mixed. Very similar to if you were doing it by hand, and then we mimic the motions of the hands to put it in place with a linear hammer. So we're starting out the gate with tool changes. That's pretty different than most printers. I think probably the best example of folks in that realm right now is probably the Diamonds folks out in Phoenix. I think they're west of Phoenix.
Yeah, Diamond Age. Yeah, I visited their site. Yeah, a couple months ago. Visited their facility, and then actually one of their build sites. Yeah, so yeah, they're pretty sophisticated, large machines. But yeah, definitely they are leaning as their kind of answer to this the building prices. I don't like to use prices so much, but like they're like, hey, we could do a lot with one machine and using tool changes. But versus like to your point, most people just have a print nozzle and they're just squirting out, cementitious ink or something to that effect, right?
Yeah. I think Diamond Age is pretty well. They're who I look to as being like, if our company exists in 5 years, theirs does too. And there's a good chance theirs exists without us.
Hey, we're all about positivity here, Daniel. So you will exist. Yeah. Let's project the vision here. So you will exist. You'll be doing great things in 5 years. You and the team.
We'll be offering very different things. I guess that's my point in that statement. Is we are like I think probably the best form for our material is multifamily row housing because of the sound class and humidification control of the earth. There's just different things we address. Whereas like we'll never do foundations or never do stem wall printing and so forth. Whereas I think there's a huge market for that. And that's what I was trying to print with the 3D printer concrete here. I got a little off thread though. Where did we start on this? popped
For
over to
sure.
Maybe.
Yeah, yeah, for sure. I mean, so you basically the basis of the question, I kind of liked where you're going with it. So like, it was a good kind of a meandering path there. The question was like, what are you guys offering within your company that's unique? So we see obviously like historically going back thousands of years, I presume, using earth for housing, for homes, and then like how it's being done currently and the things that you see fairly well, and you're using Adobe and stucco in England and the Southeast and different regions across the country. But you guys are taking it to the next level. And what you guys are offering, and you had to be a little bit, at least right now, as of this recording, it's the middle of September of 2023. A couple of weeks, you're going to be kind of unveiling something very, very cool, and then so there'll be
Yeah.
some announcements there. But at a high level, whether you announce the exact technology or not, you just kind of laid out what you're doing that's unique, that's the next level, the next stage within the space. So thank you for kind of elaborating. And that was the question. Yeah, that was
Yeah,
kind of
I can also digest that down to 2 sentences.
sure.
Using reinforcement learning and AI to drive robotics. I don't know if anyone else is doing that sort
Yeah.
of, Terran AI. It's in the name. It's not hard to figure out that we're learning every time we touch the wall.
What?
And then materials research, that deployable lightweight material that doesn't require a secondary system. Very, very rare, very seductive.
Yeah,
Um,
very, very
and
attractive, very, very intriguing to the person that's trying to like do it well, do it fast, and be cost effective. That's those elements come together, or weaving those elements together is like, oh wow, they definitely will give you second, third, fourth look at what you're doing and how to participate with you, right?
I think the last thing to add on to that is the nimbleness of the equipment. I think when you compare us to like Diamond Age or certainly Icon, um, there's going to be it'll be surprising what we do with the size equipment we have, and
Yeah, and
that's an exciting thing.
that's a good point, actually. So if people are familiar, whether they are or not, oftentimes some of these pieces of equipment that like Diamond Age out of Arizona, like we said, or Icon 3D Concrete, kind of leader, at least they're the most well-funded to have some of the largest projects going on. Their equipment it's beautiful. It's very, very large. You don't just go out there with a handful of people and set it up. It takes, multiple days. Very rather extensive piece of equipment to set up, and it can print a house fast, but like how much time did you spend deploying the equipment? And other people are using like gantry cranes and robotics. There's different styles there. They can speed up that deployment, but that's actually kind of a limitation we have to consider within the build this whole new paradigm of 3D concrete printing or some type of additive approach. How long, how much time, how many people, how much other ancillary equipment does it take to facilitate getting creating a home or habitation wherever you want to do that? So those are challenges there.
Yep.
Okay, let's talk about now the since it's we're kind of hypothetical here. What does your kind of the core building look like? And again, hopefully we're not veering into the stuff you can't talk about yet, but I think we can, since you've already deployed it. You have YouTube. I haven't looked at your YouTube channel, but what does it look like, Daniel? So you say earthen. Give us a picture. If someone really is not familiar with it, they're familiar with stick built or whatnot. What does an earthen house look like? Does it look like a beehive? Does it look like a termite mound? Like, what does this building look like, and how thick are the walls, and how do people kind of incorporate that? How do they envision their modern life, what they know, to what earthen means? Like, in my mind, there's like a disconnect. Like, I don't know what that means. Lay that up. Enlighten the ignorant
Uh,
here.
I mean, honestly, I think people looking at the proposed project for Habitat, we ended up not building that. I think they ran into permitting problems eventually with some other part of engineering on the site unrelated to us, and they decided to stick frame it to expedite it, and then they
Just
never
to get
built
it.
it.
Okay, just to get it going, yeah, or just
Yeah,
complete it.
I don't know exactly what happened, but the drawings of that project are on our website, and I'd say other than the chamfer on the front, because we wanted to show it was something unique, you wouldn't know it was stick built, or it was you wouldn't know it wasn't stick built. Um, the surface treatment's different. It's going to look like ephes or stucco or any of those sort of things that are more monolith and smooth in nature. That's different than traditional siding. And then the wall thickness, we're deploying 18 inches on the current ADU project, and we have permits pulled for this. This is public record.
Sure.
Pretty modernist looking structure. It's we're doing the like 2/3 of the second floor with this material, and we're doing it over Western platform framing, which is pretty unique. Um, but you once you're in, you'll know that's the thickness of the walls at 18 inches. So you're
Yes.
gonna if you're in like Chicago, you might think like double loaded brick commercial, where you're feeling that like, if you're at a fancy brewery and it's got those deep windows. If you've had a little different life experience and you've been to a rural straw braille, then it's going to be like that sort of thickness. And that's somewhere we're pushing constantly. As we increase the insular values of our mixes, we pull down the thickness of the wall assembly. Probably theoretically somewhere we'd stops like in, like a foot, 16 inches thick.
Yeah.
Um,
Is that mainly driving that? So what's that kind of those two design considerations, design and engineering considerations, Daniel? So you have R value, which is like the heat resistance or the heat flow through the building, and then you have the structure. Is it like I think you just kind of hinted at it. Really, it's kind of pushing the thickness now is really the R value of the build of the wall structure. Is that kind of what's driving that to increase that to be a bit thicker?
It is. I think we could probably get away with thinner this year, honestly. Some of it's just if you're going to be in a mass situation, it feels good. Like it feels good to have thick walls. It feels good to have the built-in window seating. It feels good to have those like deep window shelves. There are parts of the tradition that are like you could optimize them out,
Yes.
but at some point you're losing like what makes it feel special to do
Yeah.
so.
Yeah.
Um,
And
and then
I bet
that's
it's
like
quiet. I bet these houses they have to be pretty quiet. I mean, really, the
uh,
noise entrances like the windows and the doors, but it's got to be with that kind of thick wall. It's got to be pretty quiet in there. Is that correct?
I'll circle back to why I think the final form or what I'm most excited about in earth and construction as a deployed system is multifamily shared wall residential. The STC rating exceeds double block, which is the pinnacle of the system is now.
And STC
Um,
just so we don't drop
sound
jargon.
transfer.
Yep, sound
Um,
transfer coefficient. Yes,
yeah, I always say class, but you're right. So the STC rating is at that around block. Additionally, when compared to block, it doesn't bounce. So concrete tends to bounce sound, whereas earth absorbs.
interesting.
So you got
Yeah,
so you got a double system in place that further reduces sound. So are you gonna get Wi-Fi room to room? Probably not super easy, but you're not gonna get sound at all. So you have a very in the terms of like building affordable housing, the places
yeah.
where you tend to save money are in these things like sound isolation. So
Typically,
you're
so this and that if we just add that, so that'd be like the quality, like, well, it's brand new, but like, yeah, you kind of hear your neighbors. So like now we're talking about a way that addresses at a very, very deep level, like what normally or historically has been that of high quality, like super, like very, very soundproof, very quiet, very not, like shaking walls and things like that. So now we're going to build in the very structure a high what used to be elements of high quality, now just incorporated just as a matter of course, right?
yeah, you're taking out the most expensive form of residential wall and replacing it with the cheapest materials that outperform it.
I love it. Yeah.
Um, yeah, that's like I mean, even as like housing forms, when I think about like would it be better to build 100,000 single family homes or 10,000 10-unit condoized equity owned, like it's very clear second option. If you're talking about like land use and ultimate price point coming down and thinking about like a paradigm that actually works, I get more excited about that. And it just happens to be that the material, in my opinion, is most suited to that. And I don't think there's anything that goes toe to toe with it
Awesome,
in
man.
that
Awesome.
particular deployment.
Talk to us about, which is obviously super exciting. I'm going to show up on site with an excavator. Maybe it's a team, like a whole neighborhood community. Like you said, it does a collective, purchasing and equity share and whatnot. Let's just keep with a single family since it's a little easier to conceptualize. I
Sure.
show up ready to do it, build a single family home. And you talked to something was very interesting of like using actual material on site and using that in my walls. So obviously that's incredibly exciting. Walk me through how to the extent you can how that would work. Obviously, just stick with Indiana, and I'm going to somehow use the dirt I'm going to dig out from excavation or my foundation and use it to build my wall. Tell me how that works. I literally have no idea. It's super exciting.
Well, I mean, we're deeper nerds than most in our group. So I took 4 samples on site. I had them ran through laser sieve analysis, where they do a particle count inside a solution of water. That gives you a breakdown of clay, silt, and other various bodies in the material. the silt on my property is a little high, which is a bit uncommon. So it's likely it was filled with something at some point. So that's like step one we run. We
Okay,
dump
so
it.
some analysis, like okay, like every home necessarily wouldn't qualify, but in certain sites, in certain areas, hey, it's going to be a win or a partial win. Well, we'll go with that
I think
assumption.
it's probably like 90, 95+% of places are likely to work.
Super high then.
Um,
Okay, good.
yeah, no, yeah. If you've got clay, it's usually appropriate. I'm going to give you the two paths. This is Terran path is what I started with that laser sieve analysis. Code requires 10 tests to be conducted, 5 on compression, 5 on modulus of rupture, and then 1 on shrinkage, which is to form up different size blocks and see how much it shrinks and then see how much compression they can take. You're looking for 85 psi, so we're in a completely different class than concrete. But 85 psi, when you're 18 inches thick, you're still talking whatever. Well, a linear foot is 18 inches times 12 times 85. You got plenty of bearing capacity there.
Yes.
If anything, you could argue that concrete has been so overspec for so long that we
Yeah.
just have broken our brains around numbers. It's like you
Yeah.
never
So
need
like, we go
PSI.
into just as a sidebar, like you go into a Home Depot and like there's like 3,500 psi, 3,500
Yeah,
psi, or 4,000 psi. I literally just bought some bad concrete the other day, or 5,000 psi. Like that's like the reference number that we think we must have. But to your point, like, hang on, like let's actually be engineers, smart designers. What is the actual strength that's needed for this? Think about the numbers and not just go with doing it because we've always done it that way. That's where you're kind of getting after, right?
yeah. I mean, and this is code compliant numbers, so you can assume there's a factor of safety of 2 or 3 on them. And we shoot for 1.5 code for anything we deploy, so we're shooting in that 120, 140 psi range.
Mm-hmm.
Uh, and then our engineer of record is the engineer that wrote the code. That was a very strategic hire. So an
Yes.
advisor to our group is the person that wrote the monolithic Adobe code for the United States, the IRC addendum. And they are the ones that are stamping the first project. So we've been like pretty careful about being conservative.
Yeah.
Um, but in terms of the PSI, I think that's a number that people get stuck on until you have like a 2-minute discussion such as this, where you're like, we can do the pencil math. Do you need your house? Does your roof weigh 2 million pounds? If it doesn't, you don't need that concrete.
Yeah. So cool, man. So that is and then so then keep and continue walking us through that if you would. So then like we do the
Yeah,
analysis and yes, and get very technical and very nerdy. You said, but again, if people walk away with this, that's what I want to walk away with. It's the high level points here. So high degree that you're going to use it. Yes, there's some analysis. Yes, here's some code things. There's ways of doing it. But then again, how do I take there's actual just dirt and there's roots and grass and probably trees, and I'm gonna somehow get some decent soil out of
yeah,
that, and then somehow create a building part of the wall structure. Take me
yeah.
to that
So,
stage if you could.
in your grading, you do a scrape. So you pull off the topsoil, whatever debris. Unfortunately, on my site that we're doing the pilot on, there were 2 previous buildings and a burn pit buried in the foundation area. We got through all of that, but it cost us to lose all the soil that was there. So we're digging like a pond on the site. But you do a scrape. You take off anything that's dark. It's going to have organic matter in it. You don't want that in the mix. You don't want that anywhere, really, under foundation, anything. So you do that scrape. You make a pile of that kind of stuff to put back over top when you're done grading, and then you sort out the subsoil clay. And for the most part, there's so many folk ways to do it. You make a ball the size of a softball and you drop it. Once you've mixed in your aggregate, if that like slumps out without cracking, you're probably fine. If it splats flat, you're probably too wet. There's a lot of variability in the ways that traditionally people do this. There's things called the pencil test where you just roll the material through your hands, see how far you can roll it out before it breaks. I tend to be more on the science side just because I like the comfort of repeatability. And my intention
Yes.
is to build 100,000 homes in a couple of years, which requires some kind of scientific rigor to be deployed into the mix of materials.
Yeah.
But there's a giant window of forgiveness in this sort of deployed system.
Yeah.
But yeah, that's the simple
And then
system.
you have you
Scrape the
let's just
site.
say so we like you said, you scrape the site, you set all organic matter aside, which is normal building practice. So you can't be having like roots and fill, a type of like black organic matter in your underneath your foundation. Not good. but then you have this. So then let's just say you do end up with a relatively decent pile of the proper type of clay and silt and whatever the stuff you could use. Then you just like set it there in a pile and cover it up, and then you like then scoop it up and like, put it in a machine, and then it like makes bricks or something like that. Like kind of walk us through again, just high level, like fifth grade level here, like how this might work, and it just kind of a step, high level pictographic, process.
There are no discrete materials made, so no discrete
Okay.
items. It
Okay.
looks nothing at all like brick. Brick is a problem for us because a lot of people think that like we're making bricks and stacking them. We absolutely are not.
There you go.
So yeah,
I'm approaching this incorrectly.
yeah, no. I mean, it's a very common misconception. So cob is monolithic in nature. So each layer locks to itself all the way around, continuous 12 to 18 inches. Ours may be higher because we're lighter. But you take that clay, you mix in the aggregate you're going to use on the site. That can vary. Sand, quarter minus, other lightweight aggregates. There's all sorts of things you can put in there. And then straw or some other fiber. They use hemp, and hemp's a little hard to combine up the machines, but like reed is also common in Europe. So sand, clay, straw, or binder, aggregate, fiber, and that's all. That's what the mix is. You can add things like lime to increase PSI strength when needed. We haven't looked into that much, but a lot of the earth block people do that. A lot of the Adobe block people do that. So we get a mass that dumps out of the machine. That mass is a pile of wet earth that's fluid, and we're picking up chunks of that. They're amorphous. They could be 8 pounds. They can be 20. They're set on top of the wall in the center. We switch tools. A hammer comes across the top and flattens it, reads the topography of the side, flattens it, reads the topography of the other side, and flattens it. So it's a 3-step process working with the 5-axis arm. So we do the ends as well. That might end up being 6. I lose track on axes once you get past the 3 I'm used to.
Yeah.
But somewhere in the like 4 to 6 range is probably what someone would technically define it as. And that's where we differ wildly from other stuff, is we're thicker lifts and then we're knitted together fully. And there's no mortar between blocks. There's none of that kind of stuff.
Yeah, which is like you said, it's in one monolithic structure when you're done, which is obviously like how it's traditionally been done. If you go to some old building, it's like you don't necessarily. I mean, I guess there is masonry and stone fitting things like that, but if it's one lift, then it's just like one big thing of earth, and then of course modern materials, and fairly somewhat refined, somewhat scientific, but also, like you said, there's a wide band of forgiveness there in what you're allowed to use, which is obviously the point. If it's so refined, like it only works in this exact spot in the middle of the desert of, New Mexico, well, that's not very scalable, is it? So if it's within certain process parameters, if it's your site is likely to be able to be used, and of course, even if your site wasn't be able to use, Daniel, just to that point, like then your neighbor or across the street or something like that, there's people digging up or excavating all the time, right? Like earth, we're talking just dirt here, right?
Honestly, on my
clean dirt.
site, the clay varies in 2 spots, and I'm guessing part of it was infill because there's better clay on my site on the backside. I just can't access it to dig it for this project.
Gotcha.
So it's like, and I'll know. I actually have scheduled it. Well, I'll be late. I'm scheduled to meet the engineers in 20, 30 minutes to start the MOR testing. So we'll know if the stuff that we have is sufficient today.
Awesome. Amazing. Okay. Well, as we're taking to the final chapter, the final section of the show here, Daniel, what is, obviously I'll give you the very, very final thing. We'll let you talk about all the different platforms and different ways of getting, that you're getting your message out there and how to connect with your company here. What is, give us the vision of, and you kind of hinted at it, but give us kind of the initial vision and then the current vision of what you want to do, where you're going, and what you're hoping to achieve with your company.
I mean, scale,
Scale.
tens or hundreds of thousands of homes, high quality, affordable price point. I said I have a bias toward multifamily row housing. I think it's just I think there's better pathways in that ownership, land use, and construction, trajectory to get to truly affordable house. But I think across the board, even single family should be cheaper. And I think there's a pathway to get there with this. The materials are cheaper, and the deployment is at a higher automation potential than basically anything else. 3D printed concrete gets in the realm too. It's like once you get to full scale, then yeah, maybe it's one operator doing 10 houses at a time. It's like those sorts of things. That's where I think we link up with the ideologies of 3D printed concrete. And then it just becomes a straight materials finishing secondary systems battle. And frankly, I don't think it's really a battle. Housing's huge, and there is opinion as to what is best on all fronts. And there'll always be people that want natural materials over Portland, no matter how much of it you pull out of it. So yeah, that's kind of high level there. Interfacing with the company right now. So we've been pretty quiet, kind of in skunkworks mode. So we public with the new equipment about 10 days. And then the website's up. That's very new information on there. We released that kind of preceding the equipment. So you get a good sense of what's going on there. You can see like some like teaser shots of the equipment on there as well. And then for folks that are like deeply interested, we move on to site the week of September 18th, week of September 25th. So in there is like we're setting up the pilot build. It's in Bloomington, Indiana. And we're going to do like that public week somewhere, I said end of October, early November.
Right.
And people should reach out if they want to see this stuff in action. Yeah. So
awesome, man. And then just to kind of finish that thought, before we talk about how to connect with your company, what is the how do you see working with others? So clearly, and we both know this, the scalability. Like if we want to see 100,000 homes, let's just pick a number. You mentioned it. Clearly, that's not Daniel. Getting out there and just working harder and harder, and that. What's the vision there of connecting with partners, developers, contractors? What do you see? What's the ideal linkage that you see? I'm sure you've thought deeply about this. How do you scale that? It's more and more people across the nation doing this at scale. What is that? What is your ideal customer? How do you connect with those people?
Yeah, our target market right now, developers, mid-size, 10 to 100 homes a year. That's a real sweet spot where they still have a lot of autonomy in their company, and they're not to the point that they're starting to lose the ability to choose different materials. And they're small enough that we can offer like a pretty competitive solution to them. At present, we do what we offer is plate to plate. So it's like you put a standard bottom plate on, we'll leave you with the standard top plate. Your walls, your electric, your windows, doors are done. So they're not having to figure out how to like interface with our system. We offer all that as one package.
Right. That's compelling. Like you said, that's compelling because it's just like, okay, whatever you do your thing, and I'm going to put the roof on, right? And you just don't have to think about that, right?
The 4 to 6 trades in the middle, we offer. And that's part of the adoption of a new system is like when you leave like 3D printed concrete walls or earth printed walls or whatever, SIPS wall, any of these new systems where they're not used to like sticking a window in, you're putting the onerous on them, which is putting the onerous on their contracted labor. And there's no point in that. It's like, if you're going to adopt a new system, it needs to be as effortless as possible. And that's as effortless as possible as we can offer now. Eventually we'll take over the whole site. We'll just offer full build solution. Sure. But at present, the plate to plate wall assembly and everything in there, that's what we're offering contractors and developers.
Final random question. This is probably not really very in sequence, but whatever. Are you having to? I imagine this is much heavier than a normal structure. Are you having to? Does the engineering have to beef up the footer and the foundation? Like typical footer width is 18 to 24 inches. That's like sub freezing if you're in a northern climate. That's where I've built all my life. What's the calculation or considerations there? Just tell me. Yeah, what have you found in that area?
No change in foundation. I spec mine a little wider on the test build, a little higher PSI just to be safe. That ended up, I don't believe, mattering. Probably the only thing where it really changes is the bottom plate size. When you have an 18-inch thick wall, you do need that to all be bearing on a plate. So it ends up being like, in our case, we use plywood plates stacked up. I'd say that's probably the place where you'd be like, this is a weird detail. Other than that, we've been able to go over Western platform framing, and everything else is pretty standard.
Awesome, man.
Yeah,
cool. So final show here, final chunk of the show here. Share with the audience. I think we've talked about it already, but you have YouTube, you're on LinkedIn, you have your website. Lay out the best place for people to learn more about you and to get in contact with you, or you and the team.
The website's it for right now. If you want to grab me on LinkedIn, you're welcome to. Pretty easy to find. Daniel Weddle at LinkedIn. I don't know what the actual other parts of the thing are, but Terran Robotics, you get you there.
People can type. Yeah.
Yeah, drop us a line through the website, especially if you want to visit. And if you want to visit, I would say I don't know when this goes public, but I would say try to be in touch by like the end of the week of the 18th if you want slotted in. So
Yeah.
end of next week.
Cool, man. I probably will drop this episode sooner than later, just so people the word can get out there. But this is exciting. So, anyway, folks, that's a wrap for the podcast. We see Daniel has and his team are working on something very, very exciting. Very, the room for potential is incredible here. So, thank you for listening. Thank you for going to the end of the podcast. If you're still here with us, until next time, from Daniel, myself, and the other people here at the podcast, the hosts and the guests. HouseNow3D, spread the word, give us a thumbs up, and until that time, thank you. Hey, Daniel.
Yeah. Have a good day.